Hi, I'm Mohit Jain, and today I'll be talking about things you need to know about computer science major. Okay, before I start, here is a short introduction about myself. So, I did my undergraduate study from India, and after completing my bachelor's or undergraduate degree in computer science and engineering, I applied to a lot of schools in US, Canada, and Europe. Okay, so I actually applied to 8 places and I got admit from 3 of them. I chose University of Toronto among the three. The other admits were from ETH Zurich, Purdue University, and the third one was University of Toronto. So I got into the PhD program at University of Toronto in the computer science program and with a specialization in human-computer interaction. Uh, After completing my master's from there, I decided to quit the program and not continue with the PhD and joined Amazon in US, working as a software development engineer. I worked there for a year and later realized that I wanted to move to a research related job. So I came back to India and joined IBM Research in India as a research engineer. I've been here with IBM Research for the last 6 years. In around 2014, I thought that I should get a PhD because I am in a research lab and it would be good to have a PhD. So I applied to 3 universities, University of Washington, CMU, and Georgia Tech, the top 3 places in human-computer interaction, and I got admit from all 3 of them. I decided to join University of Washington among the three. And so right now I'm in my third year, like finishing my third year of my PhD program, and yeah, it has been going well. Okay, so that's about me. Uh, Moving on to what I'll be talking about in this video lecture. So the first question that most of the computer science applicants ask me, like, how to select the best computer science program. So that question is very relative to the individual who is asking that question. So the answer is that, like, know what is best for you. For me, the definition of best may be very different than for you, the definition of best. Okay, because for every profile there is a best university that he or she, that a person, that an individual can aim to, and they need to choose it accordingly and know where you stand. To decide what is best for you, you should know where you stand. If you are at in the like the top 0.1% of the student, or if you are in the top 1%, or if you are in the top 5%, and accordingly you should decide which university is best suited for you and where you have the highest chances or highest probability of getting accepted. Okay, so let me give you a few examples to make it clear. So first of all, let's say you are a very top student, like you only want to aim for MIT, Stanford, CMU, Berkeley, only like the top places, and you see yourself being there. Okay, so if you are a top student, then there are three options, basically three options for you. Either you apply for a research-based master's program, which may lead to a PhD. Okay, so there are these top places like Berkeley, Stanford, MIT, CMU, UW. In my personal opinion, this is like the top 5 university in the world right now in the computer science program. Okay, then there is a mid tier, which is also very ambitious, and all of them are almost like, so. If I say the number one rank goes to the top five, the number two rank goes to all of them. Okay, so it's like UIUC, University of Michigan, UT Austin, Georgia Tech, Southern California, UCLA. There are too many of them. Okay, and then there is a slightly lower tier than that, which is the third ranking of stuff, where it is UCSD, Maryland College Park, University of Northern Carolina, all of these universities. Okay, so 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 this is the one list that I want to show you. The other is that, like, you apply for a only master's program. Okay, I'll again come back to each of these programs after giving a brief overview. Okay, so the top tier is, again, most of the top places have also a separate master's program. Again, the top ones are Stanford, UW, MIT, U of T. Uh, so I would like to emphasize here that in all these places you apply for a PhD program, but after 2 years in the program and after doing either a short thesis work or giving a final exam, you get a master's degree. And after that, either you can just continue in the program or you can drop out of the program with a master's degree. So I did the same at University of Toronto. I got in the computer science program as a PhD admit, but after 1.5 years, I took like 5 courses and I had a master's thesis in my hand, which I submitted, and I got a master's degree. After that, either I could have just continued for a PhD, but I ended up dropping out of the program. Okay, so that is the only master's program, and then there are the specific field in the computer science. Okay, so even though if you're a very top student, you may have a specific field that you want to focus on. Let's say you want to work in the field of data science or artificial intelligence, or you want to work in the field of HCI, human computer interaction, or you want to go deeper into the theoretical science of computer science. Okay, so all of these, there are different places which has a main emphasis on them. Okay, and accordingly you should do your research to figure out which place is best suited for you. Okay, for example, Canada people think is not a great place for computer science in general. The US is way higher rated than that. However, there are a few places in Canada, let's say like University of Montreal, which doesn't even fall in like the top 20, 30 university in the world. However, for artificial intelligence, it is in top 5 in the world. Okay. And similarly, University of Toronto, which is in the top 10 or top 15 in the world for computer science program, but in the field of artificial intelligence, I think it is in the top 3. Okay. So just for these specific fields, there are these places, and you can try to go to such places. Okay. And then finally, I've given out a special link here, which is a highly useful link here, because based on the number of publications or number of papers that are published from each of these universities, it ranks all the universities, all the top 10, top 15 universities in each of the computer science area of research. Okay, so I would highly recommend going it here, figuring out which field you want to apply to, and based on that, which university is at the top. Okay. Uh, Again, just to briefly say that, like there are three things that I would like to emphasize here. One is that if you are a very brilliant student, try to apply for a direct PhD program. Okay, and direct PhD program at the top tier or the mid tier universities. Most of the places, after once you are in the program and or like once you are in the program and after 2 years of being in the program, you can get out of the university with a master's degree, and then or else you can continue with a to get a full PhD. The other very crucial thing is that in a full PhD program, you get the fellowship and the scholarship and every kind of funding from the very first semester. Okay, so that is very good. Like you won't have any problem with respect to money. Okay, which is a good thing. Okay, and then like even if you're not like if you are not targeting the top most of the university, but you think that like you may want to get into uh, a slightly lower ranked university, but it is high ranked in the specific field that you are targeting. That is an excellent thing to do. Highly recommended. So let's say if you are in AI or you want to do something in AI and you are getting into the MILA, which is the Mila lab in University of Montreal, highly recommended. Go there rather than going to a other New York University, NYU, or some other places where the AI is not that strong. Okay, so keep these things in mind. Moving on to the next one. So now let's say if you're a mid-range student, you're not among the top, but you're in like the top 5% or something like that. Then what is well suited for you? So again, you can apply to a direct PhD program, and you can drop out after getting a research-based master's. Okay, so most of the mid-tier and low-tier places that I mentioned in the previous slides are still applicable for you. And in many cases, you can either drop out after the PhD, or what you can do once you're done with the master's there and you want to apply for a PhD. In that case, you can apply to a top tier PhD field. So let's say you did your master's from UCLA or from NYU, and after that you think that you can go to a higher place. So then at the end of your master's, apply to MIT, Stanford, Berkeley, CMU, UW, all these places, and then you can go there. Okay, so that is a good way to actually step up in the game. Finally, so this is the thing which is very interesting and not known to a lot of people, is there are a lot of only master's program. But when I say only master's, so these are the program where you apply to a specific specialization for doing the master's. For example, there's a program called as MSISTM at CMA. So it is the program for information security and technology management. Okay, so this program is about doing a master's related to cyber security, information security, these kind of stuff, on like security related stuff. And also there is a master's of science in HCI, human computer interaction at CMU. There is also like master of science in data science at University of Washington. CMU, University of Washington, University of Toronto, all of these are like the top 10 places in the world. And getting into their PhD computer science program is very hard. However, getting into any of these other master's program where the student has to be self-funded is fairly easy. Okay, so keep that in mind. If you want to get to a top universities, you can get into any of these programs, and all of these programs, trust me, are really good. And the top profs, like the same prof which teach a computer science in the computer science school, also teaches in these programs. So you get the same professor, same kind of benefits. It's just that the student that will be there in the CS program will be of higher caliber compared to this one, but still at the end of 2 years you will get a really good placement out of it. Okay, so again, highly recommended. These are master's specialization courses or programs being offered by the top university. Okay, so this is like the key here. Go to a I think so. So the way I'm trying to put it is here, like you go to a very highly ranked university, but a lower program in that university, or you can even go to a lower ranked university, but a very higher program in that. For example, going to the Mila lab in University of Montreal. University of Montreal is lower ranked, but Mila is very high ranked in AI. On the flip side, like if you go to CMU, but you go into the MSISTM or MS in HCI program, which are slightly lower rank, easier to get in, but still you get the name tag of graduating from CMU or Carnegie Mellon, which is very high. Okay, yeah. Uh, Moving on. Now I get this question very often: what subjects will often be taught in the computer science program? So in my opinion, I have like divided them into these four categories. Okay, based on my experience at University of Toronto and University of Washington, and also the other places where my friends are studying. So there are these courses. So right now, I think the major emphasis is on artificial intelligence everywhere. Okay, so by artificial intelligence, I mean any courses which is about deep learning, machine learning, computer vision, which is basically image processing, natural language processing, data science. All of these courses fall under the same bracket, what we call as the AI related courses. Very important to take these courses. If you can take these courses in your undergrad, it's really good. Even if you have it in undergrad, take them again in your grad school. Okay, that's the first concept. Then there are a lot of these courses related to systems. When I say systems, it basically means anything, right from the very basics of databases, network security, information security, cryptography, computer network, operating systems, high performance computing, programming languages, software engineering, all of this falls under systems category, where we actually are building the systems, and these are like different components of the system that we are building. Like for building a big system, you need a database, you need a distributed computing, you need some high power computing resources, you need an operating system where you need to deploy it. All of those things combined are mostly offered in the different part of the systems courses. Finally, there is a theoretical course. No, sorry, second last, there is a theoretical courses. So this is the stuff where I'm not the right person to talk about it because I usually don't enjoy the theory courses. However, a lot of these courses get a lot of students who really enjoy them. Okay, so the courses in algorithm, because theory side is mostly, I think, it focuses a lot on the mathematics side of stuff, and it also requires a lot of like proof and theorems. So yeah, and it's pretty cool. Okay, so it's a course in cryptography, like hardcore mathematical cryptography, formal languages, automata theory, verification, algorithms. So all of those are taught as part of the theory. And the final umbrella is the application umbrella, which is my area. I really loved it. So my favorite is AI and application. However, I also enjoy doing systems, theory not so much. So in application area, anything which is related to human-computer interaction, information, computer graphics, information visualization. So all of these things, right? It's more application of the basic computer science principle to give you some output which looks and feels good. So all of that goes into the application part. Okay, uh, give me a second here. Sorry about that. Uh, Now, how to prepare for those courses in advance? Okay, so Because I mentioned you a lot of courses some of you might have taken that course in your undergrad education, and some of you will be taking it in your graduate school. So how you should be preparing yourself for the graduate school, how to educate yourself on these computer science subjects. So I think the most important thing is that you take undergraduate fundamental level courses. Take the courses in linear algebra, very crucial for learning anything in machine learning or data science. Take the courses in data science. Take the courses in vectors or anything related to mathematics. Actually, that's very helpful. Also take the courses, the basic courses in computer networks, security protocols, databases, operating systems, data structure, algorithms, Python, coding is very crucial. Distributed computing, any of this, how many courses you can take in your undergraduate education, take them and learn them properly. Most important thing, don't just like take the course to pass them, but try to get the max out of that course. Okay. And if some of these courses interest you more, then learn more from textbooks, do more projects in that area, and also like take the MOOCs, which is the online courses on Coursera, edX. Many of these courses are free on these platforms. Just learn more from these platforms. Okay. The most important thing, I think, the best way to learn about any course that you want to go deeper in is by doing projects in it. So let's say you took a course in computer security, for example, and after the end of the project, you really enjoyed the course, you liked the prof, you learned a lot of stuff, but now you think that you want to dig deeper into that. So you should go and talk to the professors, ask them if they have any kind of research project which they have in mind and where they can involve you, or you can get involved or do or help the prof in any way possible, or a graduate student or a senior student in any way possible. By that, you will collaborate with the professor, collaborate with the senior student, learn from them, learn how research is done, how real world impact is driven. So you learn all of that, and also you learn way more about the particular field than what you have learned in the course. Because whatever you learn in the course is like 10, 15 years old material. But whatever is going on is like the research paper which was published this year or last year or 2 years back. So when you're doing a research project work, you actually read those research paper and you come to know about the recent development in the field, which is very crucial to understand. Okay, so I would recommend doing a lot of projects in it, talking with the seniors, professors, trying to learn it from different angles. Okay, now what are the application strategies for computer science major? So I think there are I think strategy wise it's hard to say. I think just give your best in whatever you are doing related to computer science. However, put more emphasis on these work. So the last thing that I was discussing anyways was research projects. Here also the first thing is research projects. Just try to emphasize a lot of research projects. Try to do as many projects as possible during your undergraduate program. However, a word of caution, never do more than 2 or 3 projects at the same time. Else you will split yourself very thin and you may not end up doing any of the projects properly. So focus on one or maybe 2 projects at a time. Give a lot of time and emphasis to them. Once one of them is done, then maybe take another new project. But don't like start 5 projects at the same time. Not recommended. Second very important thing is internship. With internship, there are multiple things you learn. One, you learn that how industry works and what all skill is needed to actually be useful for the industry. You also learn like good coding practices, how real world technology company actually people in that company code, and what is the coding principle they use, how actually code goes to the ship it mode where actually it is shipped to the customer. So all of these are good things to learn. Apart from that, if you do an internship in a research lab, then you learn more about the research culture. So there are two ways of doing internship. One internship is actually in the industry where you can go and work for, let's say, Google, Facebook, blah blah, Microsoft. You do internship with a industrial company where you help in the software development side of stuff. The other internship is actually in a research lab where you do it, let's say like FAIR, which is the Facebook Artificial Intelligence Research Lab, FAIR Research Lab, or you do it in the Microsoft Research Lab or Google Research or IBM Research. In these research labs, you learn more about the research side of stuff. Depending upon where you want to go in your life, you want to build a research career or a software developer career, you can choose one or the other. Okay, but both of them are equally good and equally relevant based on your uh, aim in life. Okay. Finally, very important thing that you get out of your undergrad education is coding skill. code, code, code. Code as much as you can, participate in as many coding competition as you can, try to win as many coding competition as you can. Because coding is one skill that will help you throughout your life. Trust me on this, not only for grad school admission, after that going to a top company, either for a research or for an industrial role. Everywhere you go, if you're a computer science major, you need to learn coding. Okay, that's important. Uh, Personal statement tips. Okay, so while applying for grad school, you will be writing a personal statement, which is also called a statement of purpose. Uh, First thing, read a lot of personal statement. Read it from your friends, from your seniors, from ask your prof, or even ask people who are on DIAD that how personal statement is written. But you need to read them, whatever is available online, whatever you can get hand of from your friend, from your colleagues, from your seniors, from your professor. Just get those personal statements and read them and internalize them. Try to understand how people write such personal statement, what goes in, what is unique about each of the personal statement, what is the common general thing across those different personal statements. The more you read, the more you understand the way to write a good personal statement. Important. Second thing that like once you have internalized what goes in a personal statement, write your personal statement, then sleep on it, maybe a day. So you write in the day to night, sleep on it, and the next day you again revise it from start till end. You make it more concise, more precise, and you improve the English of it. Then again, like you do that, and you sleep at night, and again next day you revise. So you do it for a week or two. At least your personal statement should have gone through 15, 20 iterations, either by yourself or also like once you have like a good enough draft, maybe after 10th or 12th iteration, then you send it to outside to other people, maybe to your senior, maybe to your professor, maybe to DIAT folks to get feedback on your personal statement. Okay, because it is a process where you iterate over it. The more you iterate over it, the better it gets. Okay, don't try to think that you will get the personal statement right in the first go. I don't think it actually happens. Okay, so oh, I already talked about this. Ask others to review your personal statement. So yeah, ask a lot of as many other reviewers as you can get for your personal statement, as many feedback as you can get, it is better for you. Okay. Oh, tips for students transferring major to CS. So I think there is a major misconception which is there that if you have done your undergraduate study in economics or accountancy or in any non-scientific or non-technology related field, you may not be able to do a graduate study in computer science. This is completely illogical. That's not the case. It is a lie. Okay. So I know uh, a student. Okay, I know him personally really well. So that person did his undergraduate study in economics in China. Then he moved to US to join the PhD program at University of California, Berkeley in the computer science department. That is like the number one rated PhD program in the world. Although with having a undergraduate degree in economics, he moved in to do that. After that, he became a prof at CMU in the computer science department. So think of the trajectory of him. Okay, and so this is completely feasible. Another story which I know, which is very close, I also know both of these persons personally. So, but I won't be telling the names here. So this person did a undergraduate degree from India in journalism. So like media, journalism, how they work. He did an undergraduate in there, India. Then he went to Berkeley to do his PhD from the urban city planning. Okay. But while he was at Berkeley in the urban city planning, he started collaborating with the computer science department on a lot of projects. Okay. Finally, at the end, by the end of his PhD, he was more of a computer science student than an urban planning student. Okay. And after his PhD, he directly went to University of Michigan to join in the information school as a professor. Information school is highly influenced by the computer science department. Okay, because it's called as like sort of like the data science has a separate institution. Now it is called as information school. Okay, so he went there. So I think the major learning from points from these people is that whichever domain you are in, whether it's economics or journalism or dancing, painting, computational biology, biotechnology, whatever it is, you learn the basic skills of your domain. Give me a second, sorry. Oh, not here. Wait. Sorry about that. So what I was saying was you learn the basic skills of your domain, whichever domain you are in, whether it is whether it is sorry, starting again. You learn the basic skills of your domain, whether it is economics or computational biology or journalism. You learn the basic skills, and then you learn it really well in your undergraduate education. And then you try to figure out how you can align it with the computer science field. Okay, maybe you have some problem statement in that field that can be solved using a computer science algorithm. So you try to learn the very basics of computer science and try to use computer science as a tool to solve the problem in that particular domain. For example, if there is a problem about economics of different countries of developing world, how you can solve it using computer science related tool, using the technology that is there. Similarly, if you have some problem in multimedia or journalism or computational biology or like human health, if you have like a medical degree in your undergrad, how you can use the computer science to do data processing, data analysis to actually solve those problems. So this way, any field in which you have done your undergrad, you can move on to computer science or you can align yourself to being a computer science major. Okay. Finally, what can you do once you have a computer science degree? That's a good question. Maybe after once you graduate, you should ask these questions. But to know, I think this is like the top four which are listed here. The first is that like if you have a PhD degree in computer science, you can become a professor. Being a professor, I think, is the hardest job right now. Getting into the top university as a professor is very hard. Okay. I think the second thing is become a researcher. After your PhD, you can be a researcher at IBM Research, Microsoft Research. I'm very sure even Tencent has a research lab, Baidu has a research lab, Xiaomi, everybody has a research lab. So you can be a researcher there, which is a highly esteemed position to be at. Okay. Other thing is that like even with a master's, you can be a researcher like I am. But in that case, you'll be a research engineer because you'll be doing more of the engineering, while the researcher in the group will be leading the research effort. And there's a lot to learn from there. And maybe 3 or 4 or 5 years down the line, you will become a researcher and you'll be doing the same. Okay. Other thing is that like if you go into the more focus fields like data science or NLP, natural language processing, image processing, all of these things, if you have done really well in your graduate school, then you can join a company as a data scientist. Data scientists are people who actually just try to go through a lot of data, write algorithms to cut and dice the data and try to get some findings out of it, either classify it or cluster it or do a lot of things. These are technology approach that you learn in your grad school in the data science courses that you can apply after becoming a data scientist. The other thing that you can become is a software developer. Once you know coding really well, once you know the basics of all the other fields like the data science or databases and system development really well, you can become a software developer in the top places like Google, Facebook, Amazon. Okay, so these are I think like the top four places where a computer science degree can land you. But there are a lot of other places. I think everywhere right now. I know a person who did his PhD in information visualization and he is now working for New York Times. And like all the visualization in New York Times is actually done by this guy or his team. Okay, so you never know. With a computer science degree, you can be anything. I know a person who did a PhD in computer science, and then he went on to in the Stanford Medical School because all of his research was related to using data science for solving medical problems, and hence he was actually hired in the Stanford Medical School. So I think the scope of computer science is limitless right now. You can get hired into a banking sector, doing the financial stuff. Everything requires data analysis these days. There are a lot of data getting generated. Okay, so at the end of it, a CS degree can help you be part of that. Okay, that's it from me. Thanks a lot. I hope you really liked it. If you have any questions, I think I'm still available at Bayard. So contact me, reach out to me. Thank you again. Bye.